If you're still unsure how to calculate resultant force, we can look back at the previous video to understand how to do that. But I'm going to assume that you know that for this video. So for the first one, you can see that we've got 10 newtons acting backwards and 20 newtons acting forwards, which means we have a resultant force of 10 newtons, which is 20 minus 10, going the forward direction, as this object is moving to the right. So if it's moving to the right but still has resultant force acting to the right, which is in the same direction, then this object must be accelerating, so it's going to get faster, it's going to speed up. So the object is accelerating. It's speeding up and getting faster. Moving on to the next object, we can see that it's got 50 newtons acting behind and 10 newtons acting forwards, which means that it's got a resultant force acting in this direction with 40 newtons, which is 50 newtons minus 10. The resultant force is now acting behind the object, so in the opposite direction to its moving, which means the object is going to slow down, which means it's going to decelerate or slow down. So it's acting in the opposite direction to which the object is moving. The final object that we have here is got 20 newtons here and 20 newtons there, which means we've got 0 newtons overall, which means that no overall resultant force acts on that object. You've got 0 resultant force, which means it's not going to speed up, nor is it going to slow down, but because it's moving already, it's going to continue to move at constant speed. So it's going to move at a constant speed. And that is how you answer questions that are about resultant force acting on objects moving at constant speed.